Find amplitude periods and any phase shifts, horizontal translations that is, of given sines or cosine functions. Here's what we're going to do. We're going to take our general form for sine and cosine function. We're going to look at a graph, that's the graph you see in front of you, and we're going to see if we can determine the amplitude period phase shift and our midline or vertical shift. First we have to decide, do we have a sine or cosine function? And we have some points here to help guide us. So if I just use the points as my guide, I'm going to choose to write this in terms of a sine function. And I could equally choose to write it in terms of cosine as well. So I'll begin with my midline. My midline seems to be right here, right?
Yes, it does.
And that occurs at y equals what? At y equals?
Y equals 1.
Very good. So next thing we're going to do is talk about the amplitude, period, and phase shift off of that midline. Now for the amplitude, that's your vertical distance from the midline to either the top or the bottom of the graph.
Right.
So it looks like I'm going from 1 to 3.
Yes.
Or 1 to negative 1. What is that distance going to be?
That is 2.
2. Very, very good. As far as a period is concerned, this is the shortest horizontal distance where the graph repeats itself. So it looks like when I go ahead and check out the period, it's going to go from pi all the way out to what? All the way out to?
To 5 pi?
5 pi. So when I take a look at my period, that shortest distance where the graph repeats itself, it would be what? It would be?
It would be 4 pi.
Beautiful. And lastly, we have our phase shift, and our phase shift is our horizontal translation. So for the phase shift, we're looking at the origin, and we're saying we've been shifting to the right. How many units?
Pi units.
Pi units. Very, very good. So now that we're pretty familiar with the terms, let's see if we can go ahead and look at a function, and when we have its formula, come up with the amplitude, period, phase shift, and midline.
Sure.
Now the amplitude is A, and in my general form of my sine function, my A is my coefficient out front. The absolute value of that number is the amplitude. So here the amplitude is what? The amplitude is?
Is 2.
2. Very good. To find the period, well, now what I have to do is say the period is 2 pi over b. And I can read b off of my formula. It's the coefficient in front of x.
Mm-hmm.
What's b actually?
B is 1/2.
1/2. So I can find the period. The period is not a half. It's going to be found by taking 2 pi over what? Over.
Over 1/2.
Which is what? Which is?
4 pi.
4 pi. Very good. I'll write that in for my period. For my phase shift, well, my phase shift is c over b. Mm-hmm. Now I know what b is. C is going to be this number here that I'm subtracting. What's c? C is?
C is pi over 2.
Very good. So for a phase shift, gosh, I want to take c divided by b. So that would be pi over 2. I got to think about this. Divided by what? Divided by?
By 1/2.
So let me write that down. You're dividing fractions, so I guess I'm going to invert and multiply. I have pi over 2 times what? Times?
Times 2 over 1.
And now I go ahead and reduce, and I end up with c over b being equal to?
Equal to pi.
Very good. And the last piece of information is my midline or vertical shift. But I know how to get that, don't I? I go ahead and take a look at my value of d right here.
Yes.
And what is my vertical shift?
1.
1 unit. Very good. So when I take a look at the graph now makes perfect sense to me, doesn't it? I see my amplitude of 2 right off of this midline very clearly. I see my period of what? My period of?
Of 4 pi.
4 pi. And that period of 4 pi is taking me from pi to 5 pi. I see my phase shift pretty clear because I've gone to the what? To the right?
Pi units.
Pi units. And lastly, that midline that we started with, we're going to end with. My midline, clear as day, is what? It's?
Is y equals 1.
Y equals 1. Beautiful. Thank you. For the function shown, determine the period and graph one period of the function. Now we have f of x is equal to the sine of pi over 6x. The general form for sine is y is equal to a times the sine of bx. To find the period, what do? Well, we know our period, p, is equal to 2 pi over the absolute value of b. So for us, what is b? b is pi over 6. So to determine the period, we have 2 pi all over pi over 6. So let's get a more pleasant view of it. Let's invert and multiply. So I have 2 pi over 1 times, and if I invert and multiply, I have 6 over pi. And since the pi's cancel, we end up with a period of 12. Now to sketch the function, what I'll do is create my axes. Here's x, here's y, and what I'm going to do is sketch one period. So I'm going to mark the midpoint and endpoint and quarter points. And I know my range for sine, well, that's -1 to 1. I'm just going to dash in horizontal lines at y equals -1 and y equals 1. Now for the sine function, I know the sine function starts at 0, 0 for this particular graph, and it goes up and back down, and cyclic, it goes down and back up. And I've sketched one period of the sine function. Now where does the period of 12 come into play? As we go to mark the x-axis, we're graphing one period. So since the period is 12, then I'll put 12 at the end of this one period of the graph. Half of 12 is 6, I'll mark the midpoint. And then for the quarter points, halfway between 0 and 6 is 3, and halfway between 6 and 12 is 9. I have my graph of one period of the sine of pi over 6x. What is the amplitude of the trigonometric function? Is the function vertically stretched or compressed from its parent function? Well, first let's identify the parent function, g of x. The parent function is the sine of x. So as I write the general form of f of x is equal to a times the sine of x. And notice if I identify a is -4. So to find the amplitude, what we do is we take the absolute value of a. Amplitude is the absolute value of -4, and that's the number 4. So what is the amplitude of the trigonometric function? 4. Now since 4 is greater than 1, what we have is a vertical stretch by a factor of 4. Thank you. Use transformations to graph functions involving sine and cosine. What we have in front of you is the sine function, one period of it, and we have the standard form for both sine and cosine. So let's identify a few things. And we'll go ahead and start with A. A represents the amplitude. So if I go ahead and take a look at A, that's your distance from the midline up to the top or the bottom of the curve, at least for sine and cosine. B, well, B is going to allow us to figure out the period. So the period is found by taking 2 pi over B. And that's the shortest horizontal distance where the graph repeats itself. There's my period. Next we see a C, don't we? We do. We see a C. And what C does is C allows us to find the phase shift, which I'll label PS. And the phase shift is C over B. And that's just your distance from the origin, either left or right, to the start of one period. And the only letter we haven't really accounted for, I suppose, is D. But D represents your vertical shift up or down. So we'll go ahead and just write our vertical shift or up or down. And so here it would be the distance from the origin upward. So we have enough information to clearly graph one period of any sine or cosine function, and we want to use that information to graph this sine function. So first labeling, and then off we go to graphing itself, I suppose. But let's see if we can label some of this stuff. A is what? A is the
amplitude.
Okay. And that's the distance from the midline up to the top or the bottom of the curve.
Right.
4 is used to find what? It's used to find the...
4 is used to find the period.
Very good. And the period is found by taking 2 pi over b.
Yes.
And so that would be 2 pi over what? 2 pi over...
Over 4.
Which would be what it would be?
Which would be pi over 2.
Excellent. Now, next thing we see, the next number we see is pi right here.
Right.
And pi is used to find what? To find the...
The phase shift?
Phase shift. Very good. And the phase shift is given by c over b. In this case, that's what?
That is pi over 4.
Excellent. And the very last number we see is what? We see
a 50.
Very, very good. So if we go ahead and take a look at that 50, and grab a color here, that 50 refers to what? Going up or down? A shift up or down?
Shift up, so vertical shift.
50 units. Very good. Now the question is, from this information, can you see the graph? And I'm not trying to be facetious. I'm trying to be somewhat serious. What I'm going to do is I'm going to sketch a frame of the graph, if you will. So I'm going to come over here and draw a vertical line and a horizontal line, and then I'm going to dash a pair of horizontal lines. I'm going to imagine fitting the sine function within this frame. I'm going to figure out where the midpoint, end, and even quarter points would be for a sine function using this information. How? Well, about the easiest way to do it is to first just sketch the sine function to fit the frame. Go up, come down, continue down, come back up. One period of the sine function. Now when I take a look at the word period, I know the period. The period is what? The period is
2 pi over 4, or pi over 2.
Beautiful. So that's my horizontal distance, the shortest horizontal distance where the graph repeats itself. Next thing I want to do is say, what's my midline? I've gone ahead and shifted up 50 units.
Right.
So that midline is a y-coordinate of 50. And I've also gone ahead and shifted, I got a phase shift there, I've shifted to the right, what? I've shifted to the right.
Pi over 4 units.
Pi over 4 units. Very, very good. So I can kind of see the coordinates of this point right here that marks the beginning of this one period of the sine function.
Right.
Now we also have an amplitude. An amplitude tells us how far up or down we've gone from the midline.
Yes.
Looks like we've gone how many units? We've gone
10 units.
Up or down. So this horizontal line would be at y equals?
At y equals 10 plus, 60.
Very good, 10 plus 50. And this horizontal line here would be?
50 minus the 10, so 40.
Very, very good. So I have my beginning points labeled. Now let's turn our attention to the midpoint. The midpoint is sitting right here. So I'm going to go ahead and label it so you can see it. And the coordinates would be found by taking my starting point of pi over 4 and adding half a period. And the period was pi over 2, is that right?
Yes.
So when I do that, I have pi over 4 plus pi over 4.
Right.
I want to say that
is pi over 2.
Very good. So the coordinates right here would be pi over 2, comma 50, wouldn't it?
Yes, it would.
Now if I take a look at the endpoint, and the endpoint I'm going to go ahead and mark just right over here. Well, I know that I was at pi over 4 when I began. I've gone ahead and moved a horizontal distance of pi over 2.
Right.
So it looks like that value would be pi over 4 plus
pi over 2.
Yeah, and then would that be the same as 2 pi over 4, is that right?
Yeah.
Which would be what? It would be?
That would be 3 pi over 4.
Very good. So there's my coordinates, 3 pi over 4, comma what, comma?
Comma 50.
Comma 50. And I have the graph of one period of sine. When I take a look at my sine function sketched, see if you can train your eyes to see exactly where that sine function is located. We began at pi over 450. Is that correct?
It is.
We traced over, what, one period. And we ended at what?
We ended at 3 pi over 4.
Comma 50. Very good. And the midpoint was at?
Was that pi over 2?
Pi over 2. Pi over 250. And we had a maximum of y equals 60 and a minimum of y equals?
40.
40. And we can see that one period clear as day. Thank you. What is the direction and magnitude of the phase shift for the function below from its parent function? F of x is equal to the sine of the quantity x plus pi over 6 and then minus 2. So because we have a parent function of sine, I know my standard form. My standard form is that f of x is equal to a times the sine of bx minus c plus d. Now in this form, the phase shift can be readily identified, both the direction and the magnitude, because it will be given by c over b. So notice b is the coefficient in front of x. So b will be equal to 1. Now for c, we have to realize that in the parentheses is x, bx minus a number. And after done subtracting, we end up with a positive pi over 6. So that means c must be equal to negative pi over 6. So that when we have x minus a negative pi over 6, we see what's written, which is x plus pi over 6. Alright, so let me abbreviate. We have a phase shift is equal to c, which is negative pi over 6, divided by b, which is 1, and that's negative pi over 6. So with the phase shift as a negative pi over 6, that means we're going to choose for a direction left. We're going to shift left, and for the magnitude, it will be pi over 6 units. Thank you. Graph trigonometric functions that have amplitudes other than 1. And we're looking at vertically stretched or compressed graphs. The amplitude measures the greatest distance from rest. And what it does is it represents the distance from the midline up to the highest point of a sine or cosine function, or down to the lowest point. That distance from the midline down to the lowest point of the function. And it's given by the absolute value of this multiplier out front. So basically what you're doing is you're multiplying the y-coordinates by a number, and what we're seeing here is that we have a sine function in red as a maximum value here at 1, and a sine function in blue that has a maximum value at 3. So for this particular function, the amplitude is 3. And you can literally think of it as a tripling of all the y-coordinates. So when we take a look at the values of a, well, if a is greater than 1, then you have a vertical stretch. And that's what we have here. We have a tripling of our y-coordinates, and we're seeing that at the intercepts, no change in position, because the y-coordinate at the intercept is
0.
And if you triple it,
it's still 0.
It's 0. But when your y-coordinate is 1 and you triple it, now you're at?
Now you're at 3.
Very good. If the absolute value of a is less than 1, it will be a compression. Why? Because you're multiplying that y-coordinate by a fraction between 0 and 1. So if you're multiplying it, say, by a half, then what was once 1 is now what? Is now
a half.
Very good. And what was once 0
is going to still be 0.
Very, very good. So what you see in front of you here is a case of 4 graphs. And I know there's a lot of information here, but we have our standard sine function in red, and I'll just trace over it. And what I need you to see is that the other 3 graphs have 3 different amplitudes. And the amplitude of f of x is equal to 2 sine of x, means that it's twice as high at the maximum than the sine function. In fact, it's twice as high for any point in the domain of the sine function. For f of x equals 3 sine of x, I need you to see that if I take a look at where my sine function is and where 3 sine of x is, we're seeing a tripling of that y-coordinate. And I bet you know what I'm going to say next, but if I take a look at f of x is equal to 4 sine of x, you've gone ahead and you've quadrupled, I think that's a word, quadrupled, multiplied by 4 that y-coordinate. So when we're focusing solely on amplitudes, if I go ahead and give you the graph of a cosine function here in red, can we graph g and h, because these are two functions with two different amplitudes? Absolutely. You want to give it a shot?
Yeah, sure.
Okay. So let's go ahead and let's start with h first, because it's probably going to be a little bit easier of the two.
Okay.
And what I want you to do is take a look at the graph in red, and we're doing that because the y-coordinates at the intercepts are?
Are 0.
Okay, so go ahead and highlight the intercepts for the original parent function cosine.
Sure.
Great. And go ahead and highlight them in solid, if you would.
I can do that.
Super. So when I triple the y-coordinates at those points, what's the end of that sentence? Do the points end up moving?
No, they'll still be 0.
They'll still be 0. 3 times 0 is 0. 3.5 times 0 is 0.
Right.
Now go to the highest points for the cosine,
Okay.
where the y-coordinates are 1, and multiply those values by 3.5, and put the corresponding point up on the graph.
Sure.
Yeah, there you go.
You said the highest points?
Highest points. Very good. So that's 1 times 3.5 is equal to 3.5. Now go to the lowest points and multiply that y-coordinate at the lowest point by 3.5.
Okay.
So you're very good. So you're identifying that those points would fall where y is equal to negative 3.5.
Right.
Now you have enough information. Sketch away your h of x is equal to 3.5 cosine of x. Beautiful. You sketch better than I do. Very nice.
How's that?
That looks like an answer key to me. Let's sketch g of x the same way. Pick a different color if you would.
Sure.
When we sketch g of x, we're going to do exactly the same thing. We'll just speed it up a little bit. Go ahead and highlight the intercepts first on the original cosine graph, which is in red.
Okay.
And now go ahead and sketch, if you would, your highest points after you've multiplied by a half. You're going to get a compression, aren't you? Because 1 times a half is a half.
Yes, you would.
And then you'll take your lowest points, the y-coordinates there, multiply them by a half, and you can see that compression come into light very clearly, huh?
Yes, you can.
And now sketch your cosine curve.
Okay.
And you see the vertical compression of that cosine curve. Beautiful. Beautiful job.
Thank you.
Thank you, and thank you. We want to determine the midline amplitude, period, and phase shift of y equals 3 sine of 2x plus 1. Well, first let's look at a general form for a sine function, which is y is equal to a times the sine of bx minus c plus d. And just so we can arrange our thoughts, let's recognize that as far as the midline is concerned, we get this from the value of d. Amplitude, that's the value of the absolute value of a. To find the period, this would be 2 pi over the absolute value of b. And the phase shift, well, that would be c over b. So let's identify a, b, c, and d for our function that we have. And our function is y is equal to 3 sine of 2x plus 1. So I realize that a is 3. It looks like b is what? b is 2. We're not adding or subtracting a number within the argument, so c would be 0, and d would be 1. I think we have the information now that we need to move forward. First, let's go ahead and take a look at the midline. The midline itself would be y equals d, or y equals 1. For the amplitude, Well, the amplitude is going to be found by saying amplitude is the absolute value of A, and that's the absolute value of 3. Well, that's 3. Moving on to the period, we know the period is equal to 2 pi over the absolute value of B, and B is what? B is 2, so it's the absolute value of 2. And that would be 2 over 2, and that's just going to, or 2 pi over 2, excuse me, and the 2's would cancel, and we'd end up with pi. There's our period. Lastly, we need to look at the phase shift. So for the phase shift, we're taking a look at C over B. But C over B is 0 over 2, which is 0. In other words, sure don't look like there is a phase shift here. There is no phase shift at all. Determine the formula for the cosine function whose graph is shown below. So let me scan the graph, and starting at the origin, I notice that I can trace one period of a cosine function that's been vertically reflected. That'll help my thought process considerably. The standard form for the cosine function is y is equal to a times the cosine of bx minus c plus d. Now I'm going to start by looking at d. And the way I determine d is I go to the midline and realize the midline occurs at y equals 0.5. So that means my cosine function initially was shifted up 0.5. And so my value of d I can take from my midline. That will be 0.5. Now that I have my midline, I'm going to look at the distance from the midline to the maximum, as well as the distance from the midline to the minimum. And that distance would be 1 minus 0.5 or 0.5 minus 0, and that distance would be 0.5. So my vertical compression occurred, and it looks like A is equal to 0.5. But since my cosine graph has been reflected vertically, A will be negative 0.5. Now my focus turns to the period. And notice that the period of the function shown on this graph is 2 pi. So that means that I haven't done any type of horizontal compression or stretch. And since my graph has not been shifted left or right, C is 0. Well, I have my information for my cosine function. Y is equal to negative 0.5 times the cosine of x plus 0.5. Graph trigonometric functions that have stretched or compressed periods. We're going to start by just reminding ourselves a little bit about the period of a trigonometric function. Now, it's the shortest horizontal distance where the graph actually repeats itself, and it's related to the variable b. Period is 2 pi over the absolute value of b. So if I go ahead and take a look at a graph, and what we see here is a graph in red of the sine function, right? We see one period of the sine function. What we also see is the graph in blue, and what you're seeing horizontally, if you can kind of train your eyes to look from left to right, is a compression of that red graph.
Right.
So the way we get the compression is we look at b. We look at this 3 and this 1/3. And if b is greater than 1, then the function is horizontally compressed and the period is shortened, in this case by a factor of 3. And if you trace, you'll see 1, pause, 2, pause, 3 periods of sine right there. If b is less than 1, then you have a horizontal stretching and the period is lengthened. And it's lengthened by a factor in this case of
1/3?
Yep, or the reciprocal of 1/3 of?
Oh, of 3.
Of 3. Since it's lengthened, it's tripled.
I see.
So what happens is when I see my original period in red, notice, if you will, that I've gone ahead and drawn 3 periods in red. And my period of sine of 1/3 x is 3 times as large as the original parent function. So what we're going to do is see if we can use this information to graph g of x, which is cosine of 2x, and h of x, which is cosine of x over 2. And again, if your value of b is greater than 1, you will have a
compression.
And if that value of b is between 0 and 1, you'll have a stretch. You want to see if you can give it a shot?
Yeah, let's do it.
All right. So the first thing I want you to do is go ahead and take a look at h of x. And h of x is cosine of 1/2 of x. So this will be a case where b is between 0 and 1. B is a half. The reciprocal of that is 2. We're going to horizontally stretch that graph by a factor of 2. So let's start by putting a point at 0, 1 and realizing that point won't move because it's on the y-axis.
Like that?
Like that. Now take a look at the intercepts at pi over 2, 0 and negative pi over 2, 0. Their distance from the y-axis is going to now double. That's the stretching. So pi over 2, 0, that moved to pi comma 0.
Right.
And the same would hold for negative pi over 2, 0. That would move to negative pi 0.
Absolutely.
And then we'll go ahead and take a look at, we'll look at pi negative 1 and negative pi negative 1. And their distances from the y-axis will also double. So pi negative 1 would move to 2 pi negative 1. And I bet you know what I'm going to say.
I think I do.
Which is negative pi negative 1 will move to?
To negative 2 pi negative 1.
Very good. Let's see if you can sketch over this particular domain our stretched function.
And how is that?
Except for the dip, that looks pretty good. You undipping it, is that what you're doing?
I'm going to try to.
Alrighty.
There we go.
There we go. And that's definitely a stretching that we see. Let's go to g of x. Pick another color.
Okay.
Now, g of x, you're going to have a compression by a factor of 2. So that means when we start at 0, 1, we'll put a point there, just as we did before. That's right along the y-axis. No big deal. At pi over 2, 0 and negative pi over 2, 0, we're going to say, gosh, now you're going to put 2 points that are going to be half as far from the y-axis. So I want you to put a point at pi over 4, 0 and negative pi over 4, 0. And then I want you to go ahead and look at our next target points, which were what? Which were pi negative 1 and negative pi negative 1. And scoot them half the distance toward the y-axis. So scoot them to pi over 2 negative 1. And negative pi over 2 negative 1.
There we go.
Very good. And it looks like if we can have a little bit more room, we can go ahead and go back to 3 pi over 2, 0, and negative 3 pi over 2, 0, and scoot it half the distance. And then we can go to 2 pi 1 and negative 2 pi 1 and scoot it half the distance. So that would be pi 1 and negative pi 1. And that's good. And then we'll just keep repeating those shapes. So go ahead and draw in your cosine curve as you have gone ahead and put the points to help guide you. And that's excellent because you definitely have a compression there in red. So again, you take a look at the value of b. If the value is greater than 1, you have a horizontal compression. If the value is between 0 and 1, you have a horizontal stretch.
Right.
Thank you very much. Good job. I'm going to sketch the graph of f of x equals 3 sine of pi over 4x minus pi over 4, and I'll begin by just writing the general equation for the sine, and that general form of this particular function is y equals a times sine of bx minus c plus d, and here y is f of x. So I'm going to identify a is 3, and b is what? B is pi over 4. C is pi over 4, and apparently d is 0. So as I put together my thoughts, I'm going to really do this on a set of axes that I'm going to create right now. So my vertical axis is f of x, and my horizontal axis is x. And I'm going to start by putting together two thoughts. I know d is 0, so y equals d, or y equals 0, is the midline. And if that's the midline, I'm going to couple that with the thought that the amplitude is the absolute value of 3, which is 3. So my midline is y equals 0. I'll go up 3 units and down 3 units, and I'll start to put in the bounds of this sine function that I'm going to sketch, and I'm going to just sketch one period of it. Next, I'm going to go ahead and determine the period, and I know the period, well, that's 2 pi over the absolute value of b, and that would be 2 pi over 4. And if I invert and multiply, the pi's would cancel. I'd end up with 2 times 4, which is 8. So there's the horizontal extent of one period of my sine function that I have here. But the last thing I want to do is take a look at the phase shift, because I want to see where I'm really going to shift the parent function to begin sketching the graph. So I know the phase shift is c over b, which in this case sure looks like it's pi over 4 over pi over 4, which is 1. So I'll take my parent function, which is the sine function, and start the actual graph at x equals 1. I'll end it at x equals 9. Halfway between 1 and 9 is a 5. And if I'm looking for quarter points, halfway between 1 and 5 is a 3, and halfway between 5 and 9 is a 7. I'm ready to sketch my sine function. I know my sine function would start at 1, 0. It would go up to this point right here, which looks like 3, 3, doesn't it? It would come back to 5, 0. And then it would drop down to 7, negative 3, and come up to 9, 0. Now, the question says to actually just graph the sine function itself, so once I graph one period, I'm just going to extend the branches to capture the sine function. Write equations of graphed trigonometric functions. Our goal is to give you a graph of a trigonometric function and see if we can come up with the function's formula, the equation of that function. And so what I've done is I put up a function up here that you can look at as either a sine or cosine function, and I highlighted 3 points. Do you see the 3 points?
Yes, I do.
So I highlighted them to focus your eye on that part of the graph, and to make sure you and I are looking at the same part of the graph. We're looking at this part right here. Is that right?
Right.
Right there. Okay. Would that be a sine or a cosine function the way I've highlighted it?
Cosine.
Okay, so we're going to write this function in terms of cosine. And again, you can write it in terms of sine or cosine. Now, once we've done that, our goal is to see if we can come up with A, B, C, and D. And then we have the equation. Now, A is the amplitude. So to find the amplitude, I suppose it would make sense to, strangely enough, find the midline first. So I can see the distance from the midline up to it. So when I take a look at, again, I'm not trying to overemphasize this, this is my cosine function. That's the only part of the graph you really want to be looking at. So I'm going to just draw a box around it, a frame around it if I may. It's the only part of the graph you want to look at. Let's go ahead and take a look at our midline. Our midline would be where? It would be right here. Is that right?
That is right.
All right. So what is the y coordinate there?
5.
5. Very good. So that means that D is going to be 5. Well, that's pretty helpful because now I can find my amplitude. To find my amplitude, it's going to be the distance from the midline up to the highest point, or the distance from the midline down to the lowest point. And that distance is what?
That distance is 10.
Yeah, because you're going from 5 to 15 or from 5 to negative 5.
Right.
We take the absolute value and we just go ahead and write 10 is my amplitude. Very, very good. Well, let's keep playing this game. We can look at the period to help us determine B, right? Okay. So our period we have to look at horizontally. We can do that. We're looking from here to here. What is the distance from start to end? from 3 pi to 7 pi? What's that distance?
That would be 4 pi.
Very good. Now 4 pi doesn't give us A, B, C, or D, but it does enable us to find which variable.
We're trying to find B.
Very, very good. So to find the period, all we do is we say to ourselves, gosh, I'm sorry for the strong words, but it deserves it, gosh. We can take 2 pi over B and set it equal to the period, which is?
Which is 4 pi.
4 pi. Very, very good. We just solve for B. Maybe multiply both sides of the equation by?
By B.
Okay. So this would give us 2 pi is equal to 4 pi B.
Yes.
And then divide both sides of the equation by?
By 4 pi.
It looks like I have B. B is what? B is
equal to 1/2.
Very good. 2 pi over 4 pi. So let's see if we can write that in. B is going to be 1/2. Excellent job. So the last variable we have to find is what?
Is C.
Is C. Now the way we find C is with the phase shift. And the phase shift, if I think back, is going to be my horizontal distance from the origin, which in this case is what? Which in this case is?
Is 3 pi.
3 pi. So if my phase shift is 3 pi, that's equal to C over B, and I know B is what? B is?
B is 1/2.
1/2. Very good. So I can go ahead and multiply both sides of the equation by 1/2.
Yes.
So I have 1/2 times 3 pi is equal to what? Is equal to?
To C.
To C. So I know what C is. C is
3 pi over 2.
Beautiful job. So it looks like I have all the information that I need to make sure we're saying the same thing. A is 10, B is 1/2, C is 3 pi over 2, and D is 5.
Absolutely.
So we should be able to write in our cosine function, right?
Sure.
So if we write in our cosine function, all we have to do is come over here and grab a nice color. F of x is equal to A, and A was, we knew what A was 10, times the cosine of B, and B was 1/2,
Right.
minus C, and C was that very last number we found, 3 pi over 2, plus D, which was 5. And we have the graph of the cosine function. Thank you. A circle with a radius of 3 feet, and that's what we see here, is mounted with its center 4 feet from the ground. So here's the center, and it's 4 feet from the ground. The point closest to the ground is labeled P, that's what we see here, as shown in the figure below. We want to sketch a graph of the height above the ground of the point P as the circle is rotated. So these outputs would be h of x, where x is the angle of rotation. Then we want to find a function that gives the height in terms of this angle of rotation. And again, that angle of rotation is what we're calling x. So to sketch this particular graph, I'm going to draw a vertical and a horizontal axis. The horizontal axis I'll label x. Vertical axis I'll label h of x. And then I'll notice a few things. First of all, the center is sitting there at 4 feet above the ground. And since the radius is 3 feet, the maximum height would be 7 feet. 4 plus 3 is 7. And the minimum height would be 1 foot. 4 minus 3 is 1. Well, what does this give us? This gives us a minimum, midline, and a maximum value bounding off trig function. So I'll write 1 foot, 4 feet, 7 feet. Then I'll just dash these particular outputs to assist me in graphing. Now, x is the angle of rotation. So when I'm at theta equals 0, I'm 1 foot above the ground. As I proceed to rotate at theta equals pi over 2, I'm 4 feet above the ground. When theta equals pi, I'm 7 feet above the ground. And when theta equals 3 pi over 2, I am back to 4 feet above the ground. So by the time I get back to theta equals 2 pi, I'm 1 foot above the ground. So let me use this information to do two things. First, I'll mark my units along the horizontal axis. I'll mark the midpoint, pi, endpoint, 2 pi for 1 full rotation, quarter point, pi over 2, and a 3/4 point, 3 pi over 2. Now again, when theta is 0, I know I am 1 foot above the ground. When theta is pi over 2, I'm going to be what? I'm going to be 4 feet above the ground. When theta is pi, I'm going to be 7 feet above the ground. When theta is 3 pi over 2, I'm going to be back to 4 feet above the ground. And finally, when theta is 2 pi, I'm back to 1 foot above the ground. And I have the graph of the height above the ground of the point as the circle is rotated at least one period of it. Well, the next thing I want to do is find a function that gives the height in terms of the angle of rotation. So I can either use sine or cosine, but I'm going to choose to use cosine. This looks like a cosine graph that's been reflected. So if I think about my standard form for cosine, y equals a times the cosine of bx plus c. I didn't know that my cosine graph has been reflected, so that means when I look at a, it's negative. And I know the stretching factor seems to be 3 units, so I have -3. What else do I know? Well, I know my period is 2 pi, so b is 1. But it looks like my graph has been raised. My graph has been raised 4 units above the x-axis, so c is 4. I have my function, y is equal to -3 times the cosine of x and plus 4. And I have the function that gives the height in terms of the angle of rotation.